it does is get the flue gases from the flame into here. And then it needs the temperature differential between the indoor and the outdoor. You still need a chimney. Okay? So,
Is that thing powered at all? Or is it just,
It's part of the furnace.
it's part of the furnace. Here's how this works. There's a call for heat. So, you know, mechanics and heat, HVAC guys know what I mean. When I say this is the sequence that this thing has to work in. The thermostat says there's a call for heat. The house is cold. The thermostat kicks on. It starts this draft inducer fan first. The fan starts spinning. It creates a negative pressure. That fan is connected to a little pressure switch. The pressure switch clicks and says, we got open chimney. Okay? Now you can light. Then the hot surface igniter gets hot, and then the gas valve opens. That's the sequence. Why don't we just have gas, turn on the fan, and then light it off?
boom?
The government would call that an uncontrolled energy release.
You want that logic circuit to work?
Yeah. The logic circuit must work.
Yes.
These are the safeties that were also built in that this never had. This usually had a standing pilot light burning all the time. Okay? This has to, the fan has to work, hot surface igniter, and then the gas valve would open.
So you may not be able to see the draft diverter fan, but you should be able to hear it go on when you.
You will definitely hear it come on.
Okay.
You'll see it if you let the front cover off, it's right there in the front.
Yeah,
Oh,
it's right in the top of the unit, right by the draft, what used to be the draft diverter. So they put a bottom in it. The other thing is they also improve the efficiency because when the units are off, there's something that's called off-cycle losses. And off-cycle losses is when the furnace shuts down, does it lose its heat instantly? No, it stays hot in there, doesn't it? So the house is now at 70, the furnace shut off, and the whole thing is hot. It still wants to draft, doesn't it? And this one, when this drafts, it goes right up and out. There's no control over. So the cool basement air is coming in, going across the heat exchanger, and right up, 24 hours a day, right? So it's a ventilator. It vents the basement. When we did this, that fan is somewhat of a blockage in the chimney. So it improved the off-cycle losses, what's called chimney losses. Now, in hot air furnaces, they're less of an issue than boilers or steam units. Why? Mass. These things are made out of tin. There's not a whole lot of mass there to hold the heat, right? They're air. But when we go to boiler systems and there's lots of tubes and heavy steel and cast iron, guess what? That water holds heat a long time, right?
Mm-hmm.
So this cold air comes across. If it was one of these, the cold air comes across, cools the water in the boiler, and it just goes up and out the chimney. And then the next time there's a call for heat, the water in the boiler's colder. It's got to burn a lot longer time to bring this back up to a temperature that we could use to transfer the heat medium, the water, to the house. Make sense? So boilers really benefit from this because there's heavy mass, there's steel, they're cast iron, they're full of water. Okay? So this is an 80% AFUE. Where do you take your draft and your in this case, you would take it, your CO plus your draft in the same hole. Okay? Because are we getting 20% oxygen in here? No, it can't get in here. The only thing we're reading is after combustion in undiluted flue gases. Is everybody okay with this? This is actually leading someplace, folks, because you can't use that chart until you know what kind of unit you're looking at. So, 70s, 80%. AFUE, annual fuel utilization efficiency. What this is it's a government test. And they're saying that it's like the miles per gallon that the auto manufacturers have to put on your car. They're saying that unit is gonna run at 82% efficiency, okay? And the way this works is, the government sends in somebody, a third-party verifier, if you will. They watch the boilers come down the line, and they'll say, pull that one. Comes off the line, goes to the shop, in the test lab, and it's tested. And this is done weekly. We have a manufacturer in Williamsport that the guy shows up every week on different days, and he pulls one off the line, and they take it back to their test lab, and they test it to make sure that they're still producing 80%. Because there's a book out there, and I can't think of the name of it, that lists every manufacturer in every unit and the AFUE of it. Do you remember the name of that book?
Preston's Guide.
What is it?
Preston's Guide.
Preston's Guide. So if you want to buy a Coleman, and you say, geez, I wonder if that's a good unit, you can go to that book, open up the Coleman, get the model number, and it'll tell you all the information about that unit. Well, to do that, they have to be tested. So anyhow, this is the 70. It's open combustion. This is actually open combustion too. The front of this is open.